This video is on more characteristics of a square and rhombus. This picture right here is a square and this is a rhombus. One of the characteristics says that the diagonals bisect two of the angles. There's your diagonals. So what this means is that in this square right here, this is that diagonal, which means two of the corners which it touches of the square, it bisects it. So here we've got this. And I'm just going to draw these in for each of these sides, which means that these are congruent and these are congruent. The angles on the other corners are also congruent. One of the things we know in a square is that every corner is 90 degrees. So what we know is that if 90 degrees is cut in half, each of these little pieces right here are 45 degrees. So in every square, the diagonals cut every 90-degree corner in half to leave 45-degree angles on each side. The other thing we know is that the diagonals are perpendicular, which means where the diagonals meet creates a 90-degree angle. So we can draw that in here too. 90-degree angle. Same thing in the rhombus. Where the diagonals meet creates 90 degrees, which is all the way around. So we could draw this actually all the way around. And each of those would be 90-degree angles. Then the diagonals also bisect the corners, which means these are congruent and these are congruent. So all four of these angles, this, and this, would all be the same. And then these angles are also congruent. So we could draw those in as well. So now let's take a look at this rhombus right here. AEB would be this angle right here. And one of the characteristics we just learned is that the diagonals are perpendicular, which means that AEB has to be 90 degrees. DAE, so DAE would be this angle right here. And in a rhombus, the diagonals bisect the corner angles. So if this is 75, this also has to be 75. Angle CBE is what we want to find next. So here's angle CBE. So we're talking this angle right here. Well, what we know is this right here is a triangle. So if we add up 75 plus 90, that gives us, and you take that, and you take your 75 plus 90, and then you subtract that from 180, you would end up with 15. So if we know if this angle is 15, then it makes this one 15 as well, because we know that these are bisected by this diagonal. So this is 15 as well. So we can write 15 here. So CB is our next one, segment CB. And so if we find segment CB is right here, so if we know that AB is 13, we know since this is a rhombus, all sides are congruent, so this side would also be 13. AC is the length of this diagonal right here. AC is the whole length. And if we know that the diagonals are bisected by each other, we know that this right here, EC is 3, so that would make this 3. So if we just add those together, that would give us the whole length of 6. And now we want to find if angle CDE equals x plus 12, we want to find x. So for this one, we want to take angle CDE, is this angle right here that we're looking for. And we know that this one right here, if this one is 15, we know these are all 15. So since we know that, we can take our x plus 12 and just set it equal to 15, since we know this is 15. And when we solve for that, we would find that x equals 3. And you can just put that right here, that x equals 3 would be our answer for that. Here is an example with a square. FG, that is this side here, and GH, this side, we know that they're congruent. Oops. We know that they're congruent, so we can mark that. Because all sides in a square are congruent. So if FG is 12x plus 3, and we know that GH is 8x plus 17, and we know that those are congruent, we can just set those equal to each other to solve for x for this one if we want to find all sides, and that'll give us what our x value is or our side value is for each one. For this one, angle GFJ, if we look, angle GFJ would be right here. So for that, we know that that's 11x plus 1. And so I'm going to write that right up here, 11x plus 1. GFJ, so that's right here, this angle. And like we drew on the previous slide, since this is a square, these are congruent. All of our angles actually are congruent. And we know that it's bisected in a square. So we know that the big angle here would be 90 degrees, which means that this little angle right here would be 45. So you can take 11x plus 1 and set that equal to 45 to find your x. In this next question, it's saying if GFJ is 13x minus 7, so again, we're looking back at this angle, but this time it's saying that it's 13x minus 7. And if IFJ, so if we look on here, that would be this angle here, it's saying is 5x plus 25. And we want to try to solve for x. So there's a couple different ways you can do this. Knowing that these are congruent, we could say just take 13x minus 7 and set it equal to 5x plus 25. That would be one way to solve for x. The second way you could do it is, since we know in a square that the corner angles are 90 degrees, you could also take 5x plus 25 plus 13x minus 7, and you could set that to the whole angle, set it equal to 90, would be another way that you could solve it. Either way, it'll work out, and you can solve for x to find out what that value would be. In a rectangle and in a square, the diagonals are congruent, which means the length of AC has to be congruent to BD. So we could write that as AC is congruent to BD. Another thing we learned about diagonals is that all the diagonals bisect each other. So in a square and in a rectangle, each of these pieces of the diagonal is congruent. So we could say this is congruent to this, but this is also congruent to this. And all of those little pieces are all congruent in a rectangle and in a square. Each piece would be. So if this is a rectangle and AC is 2x plus 3, so we know that AC here is 2x plus 3, and the length of BD is 5x minus 6, I can set those equal to each other to solve for x. And then we can find the length of BD. Now in this rectangle right here, an example is saying angle MKO. So if we find angle MKO would be right here is 21x plus 5. So that would be this angle right here. And angle LKO, so LKO would be this angle here, is 7x plus 1. Now in a rectangle, these angles are not congruent. In a rectangle, this big angle is still 90 degrees, so the whole angle is still 90 degrees. But this diagonal does not bisect the angle. That only happens in a square and a rhombus. So to solve for our two angles here, we would have to add up 21x plus 5 plus 7x plus 1, and you'd have to set that equal to 9. This will let you solve for your x and find the two angles. And you have to remember that angles are only congruent in a rhombus and square. In this last example, if you take the figure and you put it on the coordinate plane, each vertex is located at a coordinate. And if we want to test to see if this figure right here is a rectangle, the diagonals have to be congruent, which means the length from DB has to be the same as AC. So if we just draw those in, the length from DB has to be congruent to the length of AC for us to have a rectangle. Well, if we wanted to find the length of something, we can use the distance formula if it's on the coordinate plane. So if I take a look at BD and I call this x1, y1, and I call this x2, y2, we can go ahead and set it up in the distance formula using those coordinates of the diagonals to find the length of the first diagonal. So go ahead and see if you can plug those into the distance formula to find the length of BD. And then we'll do the same thing with this diagonal to find that length. So what I did was took x2 minus x1, which would be minus 4, negative 4 minus 6 squared, plus y2 minus y1, which is negative 3 minus 9 squared. So you get negative 10 squared, which is 100, plus 12 squared, which is 144. So you get the square root of 244. Okay, when I plug that in, you get 15.6, which is what the length of DB would be. And then you need to find the length of the other diagonal and see if it matches the square root of 244. So I can call this negative 5, 8. We can call this x1, y1. And then we can call this x2, y2. And we can set up another distance formula here using these two and solve to see if you get the same value. So I'm going to pause now so you can go ahead and try that. Plug it into this equation, but use these two pairs instead. So when we plug in these values from AC, you should have gotten 7 minus negative 5, which would result in us adding those together, and then negative 2 minus 8 squared. So we squared both those, so you get 12 squared plus 10 squared, and that would give us the square root of 244 again, which equals 15.6, which is our value, our length of AC. So we know that these two are the same. When you get the same value after the distance formula, that means the lengths of the diagonals are the same. So after you do that distance formula, if the lengths are congruent, you do indeed have a rectangle. So this is a rectangle, and this is how we would show that. And you're just checking to make sure that these two values for each of the diagonals, the distances come out the same. And if they do, then you can say that yes, this is a rectangle. Hopefully your calculations came out the same as mine.